Hello everyone, so today we are going to talk about the Arndt-Eistert reaction. So let me write a general reaction. So in this reaction, the starting material is carboxylic acid, and in product side, we are adding one extra methylene group to the starting material. So to bring out this change, in first step, we use thionyl chloride. In second step, we use diazomethane. In third step, we use silver salt in catalytic amount, and also we add water. So this is a general reaction. So in this reaction, we convert carboxylic acid into another carboxylic acid, but the difference is we are adding an extra methylene group, extra CH2 group to the system. And to bring out this change, these are the following reagents we use. So now let's go ahead and draw the mechanism for each and every step. Okay, so in first step, we convert carboxylic acid into acyl chloride, and the reagent we use this called thionyl chloride, SOCl2. So mechanistically, the structure of SOCl2 is like this. Now the oxygen of carboxylic acid, its lone pair, is going to attack at this sulfur. Through conjugation, Cl group is going to leave. So we are going to generate now the Cl minus chloride ion which has just left is going to come back, is going to attack at this carbonyl center. Through conjugation, this whole group is going to leave. And this is how we will generate the product of first step, that is acyl chloride. And the byproduct is this one. Now the chloride ion, another chloride ion will come, will grab this proton, and it will form double bond here, and the chloride ion is going to leave. So this will generate SO2 gas. If you look closely, this is going to generate an SO2 gas, which is going to liberate as a gas, and HCl gas will also leave. So this part is an HCl gas. So this is the first step where we convert carboxylic acid into acyl chloride using thionyl chloride. Now the second step is going to be the addition of diazomethane. So now let's look at it. So now we have generated acyl chloride. We have converted carboxylic acid into acyl chloride. Now we are going to add diazomethane into it. So the structure of diazomethane is like this. Overall, it's a neutral molecule. We can see one positive and one negative charge. So this nitrogen lone pair will form triple bond here, and this double bond pair will collapse on carbon. So the resonating structure is going to be so in short, I have generated a nucleophile which is going to attack at this carbonyl center, and through conjugation, Cl group is going to leave. So we have generated so now this CH2 group is right here. So now the chloride ion which has just left is going to come back, and it will form a carbon ion at this center. I can write this whole molecule as N2+. So now I have carb anion. So this is going to go in resonance with this carbonyl center. Now you have to look closely. This lone pair of electron will form double bond. This R group with its bond pair is going to migrate at this center, and N2 gas will release. So this is going to form, let me give a number. So 1, 2, 3 and 4. So we have generated a carbonyl system, another double bond attached to R. So this is going to be 1, 2, 3, 4. So now we have generated a sort of ketene. So if I redraw it, it's going to be this molecule. So this dot here represents a carbon. So now we have generated a ketene. Now the main key step of this reaction is formation of ketene, and that is happening at this position. So you need to understand this position very well. So what is happening is this negative charge is forming a double bond here, and this whole bond is migrating towards 3 position, and N2 gas is getting released. So if you number them, you will be able to form this ketene molecule, which is nothing but, if I redraw, this is going to look like this one. So you need to know that in Arndt-Eistert reaction, the intermediate is a ketene. This core structure is called ketene. So now let's go ahead and let's go ahead and do the next step. So this is what we generated in previous step. And if I redraw it, I can write this one as the exact same thing. Okay, now if you remember, we are also adding water into our system. So the water lone pair is going to attack at this carbon. This carbonyl double bond will break, and it gives rise to oxygen bearing negative charge, and this hydronium ion. Then in next step, this oxygen will reform the double bond, and this double bond will grab this hydrogen, neutralizing this oxygen, and this will give the product we are looking for. We have added an extra methylene group to the system, and from where this methylene group is coming from the previous step, diazomethane. So the carbon of diazomethane is what sitting here. So this is the overall mechanism of the Arndt-Eistert reaction. So now just to recall, in Arndt-Eistert reaction, we are taking carboxylic acid. In first step, we are converting carboxylic acid into acyl chloride. Then in second step, using diazomethane, we are making it a ketene. And ketene, when react with water, it forms acid. So we have carboxylic acid. First step, we generated acyl chloride. Second step, just to let you know that in this step only, Ag plus is catalyzing the formation of ketene. So this is how we get ketene, and finally when we added water, we got the product. So once we have ketene, by varying this solvent, just because I took water, I formed acid. So by varying this solvent, we can vary the product form. So let me explain you in detail what I mean. So when we have ketene and we added water, we got carboxylic acid. Now by changing this water, we can change this product, and I have already shown you the mechanism for this step. Now the short trick is, You need to write your solvent in this fashion and add one of the part at this center and one of the part at this center. Let me explain you by giving one example. So for example, if I have ketene and I'm adding any, let's say, any alcohol. So I'm going to write my alcohol in this fashion. I will add my oxygen part at this ketene carbon and hydrogen at this unsaturated carbon. And the product I'm going to generate. And also you have to make this double bond saturated. And this is how we generate an ester this time by using alcohol. So by changing water to alcohol, we are converting acid into ester. For example, if I have ketene and I'm adding, let's say, amine in my last step. So the same fashion I'm going to write. This nitrogen heteroatom will add to ketene carbon. This hydrogen will add at this position. I'm going to saturate this double bond and the product will be amide. This time we are getting amide because I used amine. One variation can also be made here. So here we can see we used primary amine. So what if I use secondary amine? Well, no problem. I have hydrogen here. So I wrote this molecule in this fashion, added heteroatom at this ketene carbon and hydrogen at this position. And once again, we are getting amide bond. Now let's say I have ketene and I'm adding this time tertiary amine. So let me tell you, the reaction will not go. Simply because there is no hydrogen to add at this position. We have a tertiary amine this time. So just to final recall, we have carboxylic acid. We added SOCl2. We got acyl chloride. We used diazomethane, silver salt. We got ketene. And if I add water into ketene, I'm getting carboxylic acid. And if I add alcohol into it, I'm getting ester. Primary or secondary amine will form amide and tertiary amine will not react. So this is the reaction called Arndt-Eistert reaction, where you add one extra methylene group to the system. And also, for example, let's say this carbon of diazomethane is 18 labeled. Then in product, this carbon will get carbon 18. So this is all about the Arndt-Eistert reaction, and we will be solving problem based on it in near future. Thank you for watching.